So what we're going to learn today in this video about functions is how to use functions to do math. We saw the example with the happy birthday song, and it's cute, but maybe not terribly useful. So think about in a video game. Every time you get a hit or you solve a word puzzle, you want to increase your score. Well, you don't want to have to write a line of code every time you increase the score in a game. You can't do that. You want to have a function that increases it. So we need to have a way to do math. So we're going to do a very simple function, and we're going to call it square it, and it returns the square. So we have square it, and the parameter is value. Sometimes that's called the argument of the parameter. So value is what we're going to send in, and we're going to say that the answer to this is going to be value times value, because we want to square it. Now that's nice, but we need to get it out of the function. In the same way, if you were doing something where you were keeping score in a video game, you would want to return the score. So you say return answer. And it's a little weird here because usually your things are in parentheses and they aren't for return. So that's a little quirk you got to be aware of. But you'll always have mine to take a look at. Now let's have a list of numbers. 2, 3, 6, 9, and 12. And they're just numbers I picked for no special reason. So let's say for x in nums. So for everything that's in our list of nums, we're going to say, well, the square equals, and you have to say equals, square it sub x. And then we'll print x, comma, and let's print the square too. Let's print them both. And then maybe it would be nice to have a tab in there just so we can separate everything out. So let's talk about what we're doing. We have a list of numbers for x in nums. So for each number in the list. Now I have a new variable called square. I want square to equal the square root of x. So send x up here. Notice I did not call it x up here. I called it value. You generally want to give it, or almost always, you want to give it a different variable name in the function. That's called a local variable. It just keeps everything cleaner and it prevents anything in the main area from getting confused. Now we're going to return answer. We're going to put it in square, and then we're just going to print some things. And let's see if I did it right. Yep, those are returned and squared. 2 squared is 4, 3 squared is 9, 6 squared is 36. It's doing exactly like we would expect it to do. So this isn't a terribly complicated one. And we could have it do anything in here. We could have it return a cube if we wanted. I know we called it square, but we can do that. We can change the math to be whatever we want. So 2 squared is 8, or cubed is 8, 3 cubed is 27. Oh, and let's just make this program a little bit better. Let's keep it as a square. One thing we probably also want to do is we want to print, we really ought to tell the user what all this means. So I'm going to do number. Remember, /t is the tab. Yeah, and it looks much better. It's always better to tell the user what your program is doing so they don't get confused. All right. Now what we're going to do is we want to do a little more complicated math. And this is a good one because this is kind of like a banking program. What we want to do is see, well, what happens if we get some interest in a bank? And when you get interest, so let me get rid of some of this stuff here. And get rid of some stuff here. When you gain money because you invested it, you accrue the money. You don't have to call it accrue. You could call it whatever you want. So we're going to take a value in here called x. And x is going to be the amount of money in our bank account. And we're going to return x times 1.06. So what that does is it says, what if you got a 6% interest rate every year? And you could change that. Now, actually, you don't usually get like a 6% on a savings account. So that might be more like an investment or stock market one. So now we're down in the main function here. Print this program calculates your interest and the new principal. So what that means is it calculates how much money you get, and your principal is how much is in your account. Oh, and we'll tell the person it assumes a 6% interest rate. And as I said, we could change that. We could change it to a 2% or a 10% or whatever. So let's get the initial amount. And that's going to be a floating point number because we can put in anything we want. So we're going to ask the user to enter your initial investment. Or let's say deposit. Let's call it deposit. Notice I like a space after that just for neatness. And then I put in 2 parentheses to end it. Okay? So let's hang on to, that's the initial amount. And then let's say, well, the value equals initial. Because maybe we want to keep track of how much we put in initially. Oh, and let's see how years equals, now years is going to be an integer. Input, how many years would you like to invest? So do we want to put our money in for 5 years or 10 years or whatever? Okay, so for I in range of years. Oops, I got to put the parentheses just right. Now, something to notice, I did not make years a float. I made it an int or an integer. Because you can only do, at least the way this works, is we're assuming you get the money every year. We're not going to let you do it every 6 months. You have to keep it in for the full years. It just makes everything easier. So now value is going to be accrue value. It'll take whatever the current value is, send it up to the accrue function, and see what it's worth, and return it. And then maybe we want to print it. So we'll say value print equals round value, comma 2. What it's doing here is it's going to round it to 2 decimal places, which is how we see money. Now you might say, well, why didn't you just use value there? There is a reason for that. We don't want to round value because every time you round, you could gain or lose money. And the banks don't want to do that. They're going to keep them out to a bunch of decimal places and just do it that way. If you saw the movie Office Space, they actually tried to steal money by doing that by the rounding used in the bank accounts. Now we ought to print what it is. Your account is worth, let's see, however many dollars. And that'll be value print. It's just a rounded thing. You don't have to round it. You could print all those decimals. But we're usually used to seeing money, you know, $1.25. We don't see 1.2499 except with gas. And usually they're just doing that to make it look like it's a little bit less. After however many years. Now we don't want to use I years because that means 0. Remember, Python and computer languages start from 0, so we'll do I plus 1 years. So this whole line here is just to print it. You could have printed it more simply too, but I want to print it something nice. So let's see what we can do with this function. Yeah, we got to save it. All right, so let's put $100 in, and we'll invest it for 10 years. So look what happened. It's worth 106 because of 6% interest rate after the first year. But now it's not 112, it's a little more than 112. It's 112.36. Because I was getting interest not on $100, but on $106. And then it keeps doing that. It always gets the interest based on the last value, not the initial. And so after 10 years, now you might say, well, after 10 years, it should be worth 160. No, it's worth more than that. It's 179, almost 180, because the interest compounds. So again, if we look back here, we use this function because I don't have to type it 10 times. For example, if I want to do $100 and I want to invest it for 25 years, it just keeps calling that function 25 times. Oh, look, my money's 4 times what I invested. So that's the value of the functions. And I know sometimes you could do them with a for loop also. You could do something very similar. But functions are really a good way to encapsulate, they call it, to kind of put everything that it's doing in one location.